Let's take a moment to look at a kind of system that we're likely to see in a typical application. 0.03x plus 0.07y equals 14.25, and 75x plus 225y equals 43,125. Now this is a perfectly good system, and I could at this point go ahead and solve it using the techniques that we met in the first video. However, these numbers are all kind of long and awkward and time-consuming to write, and I think that it's possible that when I'm writing them out, I'm likely to make mistakes. If I work with simpler numbers, so smaller, shorter, easier to write, I'm less likely to make mistakes. Looking at this first equation, I see that these decimals are all in the hundredths, which means that if I multiplied both sides by 100, I could work with all whole numbers. More than that, this whole number and this whole number, after multiplying, would be just one-digit whole numbers. So I'm going to do that. I get just 3x plus 7y equals 1,425. Looking at the second equation, it looks like all of these numbers are multiples of 25, right? 75 is a multiple of 25, 220, yeah, they're all multiples of 25. So I can take the second equation, if I like, and divide both sides by 25. And I'm writing this as times 1/25 just because it looks a little bit neater on the page. So what do we get? 75 divided by 25 is 3. 225 divided by 25 is 9. This number divided by 25 is 1,725. So this original system, after I simplify a little bit, becomes 3x plus 7y equals 1,425. 3x plus 9y equals 1,725. Ooh, we got a nice bonus out of this, didn't we? We noticed that these two numbers, we noticed that the coefficients of x are very closely related. In fact, I think if I multiplied this first equation on both sides by -1, I'll get negative 3x minus 7y equals negative 1,425. That's all I'm going to need to do for elimination, isn't it? Because now when I add the left-hand sides, I'll get 0x plus 2y equals 300. Divide both sides by 2, I'll get y equals 150. And now I'm going to break my rule about going back to the original equations. I'll go back to both my original equations to check my work, but these equations are so much nicer to look at, I'm going to use this equation to find x. I get 3x plus 1050 equals 1425. By the way, I am doing arithmetic on a calculator off camera. I'm not doing this arithmetic in my head. Subtract 1050 from both sides, and we get 3x equals 375. Divide both sides by 3, and I get x equals 125. So I think my solution is x equals 125, y equals 150. And now I did a lot of manipulation, so I'm going to check that. 0.03 times 125 plus 0.07 times 150. I'm just going to enter this into my calculator. That does indeed equal 1,425. 75 times 125 plus 225 times 150. That does indeed equal 43,125. So our solution really is correct. Now I'm going to give you one of these to try. Solve the system 2/3 x plus 3/5 y equals 10.2 and 200x plus 500y equals 5300. Simplify first so that you can work with easier numbers. Pause the video and try this now. Okay, looking at the first equation, what makes the numbers unpleasant is the presence of all those fractions, right? So in order to simplify this, we want to get rid of the fractions. I'm going to get rid of the thirds first by multiplying both sides of this equation by 3. Right, when I do this multiplication, I'll get 3 times 2/3 x plus 3 times 3/5 y equals 3 times 10.2. 3 times 2/3, of course, that'll just be 2. 3 times 3/5, I guess that's going to be 9/5. 3 times 10.2, that's going to be 30.6. Now I'm going to get rid of these fifths. I'd like to multiply both sides by 5. 5 times 2x, that's going to be 10x. 5 times 9/5 y, that's going to be 9y. 5 times 30.6, that's going to be 153. So that multiplication got rid of the decimal on the right. The second equation is a little bit easier to simplify. I see that these are each multiples of 100, so I can divide both sides by 100, and that's pretty straightforward. Distributing, I'll get 2x plus 5y equals 53. So after simplifying, my system becomes 10x plus 9y equals 153, and 2x plus 5y equals 53. And this is very nice because I notice 10 is a multiple of 2. So if I multiply both sides of the second equation by, say, -5, right, my second equation becomes negative 10x minus 25y equals negative 265. And now if I add the left-hand sides together, x is eliminated. I get negative 16y equals negative 112. Dividing both sides by negative 16, I'll get y equals 7. Now that I have y, I'm going to choose this equation to get x from. X equals, subtracting 35 on both sides, I get 2x equals 18. Dividing both sides by 2, I get x equals 9. So my solution ought to be x equals 9, y equals 7. I'm going to check that in my original equations. 2/3 times 9 plus 3/5 times 7. I'm going to put that into the calculator as 2 divided by 3 times 9 plus 3 divided by 5 times 7. And that does indeed come out to 10.2. Second equation, 200 times 9 plus 500 times 7. That does indeed come out to 5,300. So that solution actually works.